Okay, in this video we're going to talk about manipulating the value of K and the reaction quotient. There are three ways in which you can manipulate K: the coefficient rule, the reciprocal rule, and multiple equilibria. When the coefficients are changed by a certain factor, then K is raised to that factor. For example, see I have a 2, a 1, and a 6 for my coefficients, and those numbers end up being my exponents. So if I change those values, let's say I divide them all in half, well then this becomes 1, this will become 1/2, and 6 will become 3. And what I have done is I've changed the exponent, I've divided my exponent in half. So what you need to do is you take your original K value and you change its exponent to 1/2. If you doubled everything, then you would simply double the exponent. If you triple everything, then you simply triple the exponent. The reciprocal rule. When a reaction is reversed, the new K value is going to be the inverse of the old K value. For example, this right here is going to be products over the reactants, d to the 6th, a squared, b. So if I flip this reaction like this, then I would have to flip my products over the reactants. So it's just K is going to be 1 over the original K value. Okay? So if you flip a reaction, it's 1 over K. When two or more reactions are combined, the new equilibrium constant is the product of all the equilibrium constants from the individual reactions. For example, this first one right here, K would equal d to the 6th over a squared times b. This reaction would have a squared times f over e cubed times b. Notice that these two reactions add up to this reaction. Okay? Just because these reactions add up doesn't mean that you add your K values. K1 times K2 equals K3. So the K of this reaction times the K value of this reaction will equal the K of this reaction, because these reactions add up to this reaction. The reaction quotient, we went over this in class. Remember, Q is where you're at, K is where you're going. So if I give you a K value of 0.042, and I give you a value for the concentration of SO2Cl2 and SO2Cl2, just plug them in like you're solving for K. But you're not solving for K, you're solving for something called Q. And then you compare your Q value to your K value. So I'm going to plug these numbers in right here into my K expression, but it's going to be solving for Q. Plug in my numbers, and when I solve, I get 15.6. If you'll remember, K was 0.042. So Q is larger than K. So therefore, I am currently way over on the right-hand side of this reaction, and I need to reach K, which is a lower number, so it's further left. So the system has too many products, so I need to continue towards the left. The reaction will proceed to the left to try and reach equilibrium. So when Q is greater than K, the reaction proceeds to the left. It will continue to increase the concentration of the reactants, and the products will decrease. When Q is smaller than K, the reaction will proceed to the right. It will continue to increase the concentration of products, decrease the concentration of reactants. When Q equals K, you are at equilibrium.